Hi, my name is Juan, and my project is on Dylan. Dylan is a high level multi paradigm programming language that blends functional and object oriented programming into one unified system. What makes Dylan interesting is how dynamic and flexible it is. It supports first class functions, closures, dynamic typing, and multiple dispatch, while also providing a clean, readable syntax that feels surprisingly modern for a language developed in the early 1990s. Dylan was originally developed at Apple during a period when the company was exploring new operating systems, advanced development tools, and more efficient programming models. Apple needed a language that was flexible enough for rapid prototyping, but still strong and structured enough for building full scale applications. Most languages at the time either lacked the expressive power developers wanted or weren't suitable for large, maintainable software systems. Dylan is positioned at a really interesting point in programming language history because it was shaped by several major influences and it also went on to influence other languages. On the left side of the slide, you can see some of the languages and systems that it inspired. Lisp and Scheme contributed its functional foundations, things like first class functions, recursion, closures, and symbolic processing. The Common Lisp Object System, or CLOS, contributed many of Dylan's most advanced features, including generic functions and multiple dispatch. On the right side, you can see how Dylan influenced later languages, like Python and Ruby shared Dylan's focus on clean, readable syntax and multi paradigm flexibility. Julia takes Dylan's concept of multiple dispatch and uses it as a centerpiece of its entire design. And modern languages like Swift continue the idea of supporting functional and object oriented styles in one language. One of the things that set Dylan apart from the Lisp family is its syntax. Instead of relying on parentheses for everything, Dylan uses a much more structured block based syntax that feels familiar to developers today. It uses keywords like define method, if, else, for, and end to provide a clear, readable flow. This makes the language easier to understand, especially for people who aren't used to traditional Lisp notation. Dylan's control structures are designed to be readable and intuitive. Instead of symbols or complicated patterns, the language uses English like keywords such as if, else, and end, which makes the logic flow very clear. This helps reduce cognitive load and makes programs easier to maintain. But the standout feature is Dylan's approach to its functions. In most object oriented languages, methods belong to classes. In Dylan, methods belong to generic functions instead. You can define multiple methods with the same name, and Dylan will automatically choose the right one based on the types of all arguments. This feature, known as multiple dispatch, allows developers to express complex behavior very naturally. Dylan's object system is one of its most sophisticated and innovative features. Instead of tying methods directly to classes, Dylan organizes behavior into generic functions. This means you can define many different methods for different combinations of argument types, and the language will automatically figure out which one to call during execution. Dylan classes are built using slots, which can have optional type annotations, default values, and access control. The system supports mixins and multiple inheritance, giving developers an incredible amount of flexibility when modeling complex data structure. The code example on the slide shows how defining behavior for shapes becomes extremely clean using generic functions. Dylan's object system was far ahead of its time and is still considered advanced. Dylan also incorporates many of the most powerful features of functional programming. It treats functions as first class values so they can be passed around and manipulated like any other data. Closures allow inner functions to remember their surrounding environment, making it easier to build patterns like callbacks or stateful function generators. Higher order functions are natural in Dylan since functions can take other functions as arguments or return them as results. Dylan also encourages expression-based design, meaning many constructs return values rather than forcing everything into statements. One of the features Dylan inherited from Lisp is its macro system. Macros in Dylan allow developers to extend the language by creating custom syntax or mini languages. Unlike simple text substitution macros, Dylan uses hygienic macros that ensure that generated code doesn't accidentally interfere with user-defined variables or functions. Macros allow developers to introduce new control structures and abstractions that feel like native parts of the language. The main tool chain for Dylan today is the Open Dylan ecosystem. It includes a compiler capable of generating optimized native code, and the ability to switch between dynamic exploration and compiled performance is part of Dylan's core design and philosophy. However, the ecosystem surrounding Dylan is relatively small. The library support, community involvement, and documentation are far more limited compared to mainstream languages. Still, the tools that do exist reflect the language's original ambition to support both rapid prototyping and serious software development. Dylan's greatest strength is how seamlessly it merges functional and object-oriented programming. It gives developers clean syntax, powerful abstractions, and advanced features like multiple dispatch that allow for incredible expressive code. Even today, most mainstream languages don't support these type of features. Another strength is its hybrid approach to typing. You can write dynamic, flexible code when you're exploring, and then add type notations later to optimize performance. Even though Dylan wasn't widely adopted, it had a lasting influence on programming language design. Python and Ruby reflect Dylan's focus on clean, readable syntax. Julia takes Dylan's idea of multiple dispatch and elevates it to the core of its own design. And Swift continues Apple's tradition of supporting multi-paradigms in one language. Dylan also had significant limitations that ultimately prevented it from becoming mainstream. Many developers at the time weren't familiar with concepts like multiple dispatch or generic functions, which made Dylan seem intimidating. Apple decided to discontinue its Dylan's project as a part of a broader restructuring, leaving the language without corporate support at a critical moment. Because the ecosystem remained small and there were fewer libraries and tools compared to other languages, Dylan struggled to compete with rapidly growing languages like Java, C++, and later Python. These limitations, combined with the lack of industry adoption, ultimately stopped Dylan's evolution. In conclusion, Dylan stands as a fascinating example of how programming languages evolve and influence each other. It merged two major paradigms in a way that was incredibly forward-thinking for its time. Even though Dylan didn't become mainstream, many of his ideas live on in the languages we use today. Dylan showed that language design can be both expressive and structured, and that advanced features like multiple dispatch and flexible syntax can make programming more powerful without making it harder. Its legacy is a reminder that even experimental languages can have impact on the direction of software development.